Hello viewers, welcome back to the Multimagic channel. Hope everyone are having a great time with the video series segment or the video series playlist in our Multimagic channel. So today is the session 6 on this particular video series. In this session we will discuss how to convert camera frames to RGB images. In other way, how to capture frames from the camera or the webcam and how to convert those into the RGB frames in the real time. Okay, so before deep diving into this session, so let's quickly recap what we have done in the video series segment. So actually we started with how to convert an MP4 file to RGB images. In other ways, we'll be reading the MP4 file and finally we'll getting the RGB images from that MP4 file. So we use FFMPEG APIs, AV read frame, and then while reading the frame we will be getting the packets, and those packets, just for the testing purpose, we are writing it into the file. And after we got the packets, we are just decompressing it and getting the actual data. So this is with the help of this AV codec receive frame. So these AV frames are written to the RGB images. We have our own function which converts AV, how to dump the AV frame to RGB. So the code has been already shared. I will mention the links in the description section, and this is what we have discussed in the session 2. It's simple that we have an MP4 file, we read frame by frame, and we save each frame into an RGB image. And these are the API that we follow in the FFmpeg APIs. We need to, and for this we need to get the input format context ready of the FFmpeg. So that's we discussed in the session 2. So in the session 3 we moved on to session 3 and 4. This is where actually we explore a bit more, where we convert the RGB raw images. So now we have this RGB images, and these RGB images we convert into YUV images. So we have a specific FFmpeg APIs, swscale APIs, all those things, and we have converted this into YUV plane. And the next session we have dumped this YUV plane data into the AV frame plane or AV frame for structure, and then we have sent this to AV codec send frame, and this frame will actually compress this, and then send frame will send the raw frame, and AV receive packet. By the time here we'll be getting the compressed packet, and that information will be writing it to the file. So here you have to remember we have supplied like around 5 to 6 different images, and those images we are writing into the file, assuming each second will be displaying different images. And in order to achieve this, we need just the output context. So output means here the compressed format, input means is the decompressed format. So since we are only here we are only writing the images are available in the form of this, we don't need any specific input context, we just need the output context. So whereas here we are reading from the file, so we need input context. Here we don't need any output context because we are just writing it into the RGB images. So in the next session, in the session 5, actually we made use of both input context and the output context, and we have declared video decoder, audio decoder, we prepared all the parameters, all those things we have declared. But the simple thing is, we just, with the help of this API AV read frame, we just started reading. This is the camera images, this is not the RGB or the YUV images, this is just the data coming from the camera, and from that camera we're continuously sending the packet. So here we are getting one packet here, and then we'll be receiving that frame, and this frame is a raw frame, and this raw frame we are encoding it like AV codec send frame. Now this, in this particular thing, we will be compressing it with whatever the output context we have declared, what are the codec format, all those things are declared. So according to that it will compress, and then finally we'll be able to receiving that packet here and then write to the file. So this is how we are progressing so far, and session 6 is like a pretty much simple thing, but instead of reading from the file and converting into RGB images, we are reading from the camera and converting that into the RGB images. So here we have the FFmpeg input initialization context. We allocate all the memories here, and then later we start reading the data from the camera, and then we continuously get the data, and then we are just sending the packet, and then we receive the frame, and this frame we are converting into the RGB images using the FFmpeg APIs. Okay, so this is what we'll be discussing in this particular session. So let's quickly go into the code section, how we have done it. So this is what we have been doing. So camera to frames, and yep, these are all just the things needed. Video stream index, and as we mentioned here, we don't need any output context, we just need the input initialization. So AV format, AV input format, and then AV codec. So these are all the 5 structures we needed, and this is for to read the data from the camera, and these are like basic input frames and the time base I just have declared. So let's start into the main function. So first we have done is FFMPEG input initialization. So let's quickly recap, or let's quickly do what we need to do in this particular. So first, this is the null pointer, and we need to and we need to allocate the memory for this null pointer here, and then my bad, 1 second. Okay, I hope this way it will be much better, so I can parallelly explain, and then you can just see what is happening here. Yeah, so so in the FFmpeg input initialization case, so first we need to allocate the memory for this input format context. So this is one of the structure in the FFmpeg. So we need to just first allocate memory, and then this is a must, AV device register all. So this is needed. It ensures all the hardware devices attached to this particular machine, like webcam or any external camera or G Pro camera, GoPro camera like that you attached. And then here you need to allocate this input format. So this input format is, I'm telling, okay, my input format is not from file now, it is coming from the dev/video0, which is my webcam, and the format I'm getting is this I format, so video fully next. So this is the driver actually. So I'm mentioning the device, from which device I need to capture. It's not from input file, it's from the camera, and from the driver, respective driver name, the format name, video fully next to. So by passing these two, now the camera context is initialized properly. So now you need to find the stream, like whether in that input, whether we are getting audio stream or video stream or all the whatever it is coming. So for now, since this is a video series segment, I'm just focusing on the video stream. In the next phase, we will be seeing how to play with video as well as audio in real time both. So we just need to extend this code to support the audio also, but just for the simplicity point of view and from the building blocks point of view of the video series, we are just for time being, I'm just focused on this video segment on the video. So now we identified the video stream, and we just initialized the video stream index, and here we just declared the okay. From that, now we can get the input frames because this iStream is now you're telling AV format find stream info, and this whatever thing is there, we are allocating this to this, and here now in the stream you will get all the streams, and we'll be getting input frames and the input frames per second, input time base. So once these two parameters, it will be handy later. So now we are telling, I'm just printing okay, I'm capturing the camera, and I'm able to find a video stream from that camera, and I'm able to read how many frames are getting and what are the timestamps or the time base for that frames, which is all important for any video decoding or encoding. So now actually we need to start allocating the decoding context. So this is the input codec context video. So here whatever the allocate input codec video, whatever thing is there, we have just whatever structure we populated here. Yeah, here actually once the video stream is detected, we are finding what is the decoder, what is in which format that particular file is using. So here we will be getting the codec ID. So typically here, if it is an MP4 file, you'll be having some kind of video codec ID, like it can be X265 or it can be MP4, or it can be any other video codec ID. Since it is coming from the camera, the codec ID here, it will be raw video. So I have shown this in the list. So now this, actually in this case, the raw video means the packets and the frames will be almost a similar data except the headers. So now the video, now you got the video decoder. So the decoder context is ready. So now I'm allocating the memory here for the decoder context. So now we are just preparing up the FFmpeg, all structures we are just initializing. So we need to initialize it properly. So first you need to allocate memories. First you need to find the streams, and after finding the streams you need to allocate the decoder context. So now once the decoder context is allocated, we are copying all the parameters of that input format context to this particular decoder. So now I'm finally printing all my decoded parameters here. So what is the codec ID, what is the pixel format, what is the frame rate, what is the width, height, all this information I'm printing here. Let me expand this here with, yeah. So now actually, yeah, so now we have prepared the video decoder, and we need to open that video decoder here. So now the input format context is ready. So now once the input format context is ready, so now I am telling I will just create a dummy frames for this to store the raw frames. So this, I just allocate memory, but there is no data inside this frame now, and I'm allocating a packet. I'm just initializing, there is nothing inside this packet now as of now. And then to resolve the streaming present timestamps, I'm just declaring the present times is a value as 0. I mean, like you can see here, you win 64 all zeros, and then I'm just capturing the camera data for X number of seconds, like 5 seconds, 10 seconds, like that. So for that, I'm just capturing the current time clock here using the std chrono C++ library. And now actually here we are actually starting our processing block here. So here we need to tell, okay, AV read frame, and here I am passing my input format context. So my input format context is nothing but I need to, it will read the data from the camera provided the input format context is been initialized properly. So we have written error conditions, all those things in the FFmpeg input initialization part. So initialization part plays a very key role if you want to play around with the FFmpeg APIs. You need to know which and all APIs are needed to allocate the input format and the output format, and how to play with the different input formats and how to play around with different output formats, and for which output formats are not required, and for which input formats. So all these things, so it's all about FFmpeg abstraction layer. It's all lies in the initialization part. The processing part looks almost same. So it just revolves around this AV read frame, send packet, receive frame, send packet. So all these 4 APIs are constant, but remaining initialization parts, which APIs to use, which APIs not to use, all those things are important. I mean, while practice it comes, we also started in the initial days we were also not sure, but slowly we are getting more knowledge on which APIs to use in which context. So now here, after reading the frame, I'm telling, okay, the frame has both video and audio, but I'm not a frame can be a video frame or it can be audio frame, but since I'm only interested on compressing or extracting, or I want to do my process on the video frame only. So if it is a video frame, I'm just preserving the initial present timestamp, and then later I'm just resetting it here. I'm just storing the actual, and then I am just using my offset here, and same I'm following for the DTS, duration timestamp, and PT stands for present timestamp. Now simply here I received one packet. Okay, so this is since it is from the camera, it is almost uncompressed, but from the file it will be compressed. So once I get the packet here, so I'm just checking, okay, if the response is, I'm just sending the receive frame. So here I will be getting the uncompressed frame or the raw frame. So I got the raw frame, which is the data is stored in the AV frame. Okay, so now now almost we got here. So now I'm just printing the AV frame size here, and then if I'm getting the size. Why I use it, this is because while printing the information, I got to know that whatever data, whatever my camera is capturing the frames in this format. So here I hard coded it, but actually we need to pass it on as a parameter from whenever you read from the input codec context. So what I meant to say is in the FFmpeg initialization, yeah, here we are getting this pixel format. So maybe I can store this in a specific variable and reuse it later. But anyhow, since I know that what is that format coming, I just hard code it here, and then AV get image get buffer size. So I get the frame size, and I'm printing all the details here. I'm just printing the which frame counter, I mean frame number, present timestamp of that frame, duration timestamp of that frame, size of the frame, width of that frame, height of that frame, pixel format. So all these things. So now from the camera, I am able to get the frame of that particular time stamp. And then I'm writing that, and this is the file name. So I'm just writing to this path camera raw frames pgm events. So this is my counter. So pgm underscore 1 2 3 like that it will be there. So now this is the one more important function. So I'm just saving my frame to an image here. So let's see what is happening here. So here I declare a software context. Okay, software I mean scaling context. This is called a scaling context. So if you can just go here, yeah, it's like as a W scale. So this is in the head of FFmpeg lib as W scale. So since why I'm require this context is a scaling context, because I just want to convert, I want to scale a UV22 format to RGB format. So I need to scale it. So for those APIs are provided. So my destination frame I want is RGB frame, and this is the format RGB24. R24 means for R 8 bits, G 8 bits, B 28 bits, total 24 bits, and frame and width I'm just using the whatever the source frame. So now I need to allocate the memory for the buffer. I mean allocate the buffer. After allocating the memory, you need to allocate the buffer to store the RGB frame data. So now this is the buffer allocated 32. Okay, and this is the alignment actually. And now you need to initialize the context. So the software context is null now. This one. So now I'm just allocating the context. So the context is, this is my source frame, and my source frame format I want to convert into my destination frame format, whose width height is this, and then this, and I want the scaling algorithm to behave in a such way I will go for bilinear. So there are a lot of different scaling formats are available: fast linear, bilinear, bicubic, point area. So I'm not 100% sure on what each different formats behave, but you can play around with how these particular choosing different scaling algorithms will help us achieve different things. But for now, based upon our understanding, the bilinear is good here. So this is here the scaling is not done. We're just preparing the scaling context from which format to which format we need to do. Okay, so now once everything is set, now actually you can scale it. So when you scale it, I am passing the actual context this, and then I'm telling whatever data is there inside my source frame, copy to my destination frame, RGB line size. Okay, so yeah, so this frame data I am now copying it to the RGB data, and by default it will take care of all the scaling factors, conversions, whatever need to take in care, because all these things we mentioned here in our SWS context here. Okay, so now once we got this data, it is inside now RGB frame data. So now I am saving this RGB data into a file. So here I am calling one more function called ppm save. So where I am converting this RGB frame data into, this RGB frame data, I'm writing it into a file. So this is the file name, and I need this width, height, line size data. So what happens inside this ppm save, sorry. So it opens that particular file name, and then yeah, it starts writing while loop unless and y is equal to y0, it takes this and then you write this buffer plus I star wrap 3 comma 1 xi so star 3. So this is for it means that RGB. So since three planes are there, three formats, three color segments, so we are taking care and ensure it all the data is copied. So this is how you write an AV frame data, which is a raw frame, into an image with the help of, after scaling, this is how you write into the file. These are the two key functions, saving it to the image, at the same time how to convert a frame into image. Okay, I mean internally this uses here, but you need to save this AV frame into a image. So and for that you need to have context, and once the context is ready, you will just scale it, and that's that new data you are writing it, calling this ppm sim, and this will automatically write the data into a file and save it. Okay, so now after that you will be just deallocating all the memories here, and then you will be freeing all the context here. So once this is all done, it keeps on looping. Once whatever time seconds you passed in the command line argument, after that particular times has executed, it breaks, and then it will finally free all the memory, and then that's how you save all the images. Okay, so now let's run it. Before running, I will just stop my capturing process here, so that way, yeah. So now let's go to this project, camera to raw frames, and then let me go to the build folder. Okay, so I will just remove it, and then I will just build it. Okay, so the CMake is ready. So now I will just build a project. So it is capture frames. It's linking, it's going on. Okay, so now let's quickly go to this folder called raw frames, and let me delete all these things inside. So now again let me go to the build folder, and now just compile this, capture frames. I'll capture for 5 seconds. Okay, it started. So all the information has been, so 5 into 30, maybe 150 frames, a little bit more you will be get, and after that it exited from the loop. So you can see here I am getting the video decoded raw video, and then the video stream details, codec ID, pixel format, resolution, bitrate, frames per second, and time base. And this is my each frame info, PTS, DTS. You can see here I have reset it, so it's a starting frame. So it is showing a 0, and then 640, 480. Yeah, so everything looks good here. So all these frames, we are parallelly, each frame we are writing into the folder. So now let's quickly see what is there inside the folder. So now if you go here, so raw frames, so this is my, okay, sorry, I need to open it here in the folder. Let me, yeah, so let me go here. It's in the video basics, camera to raw frames, yeah, close to 180 frames should be there, because we have captured, yeah, so you can see it's slowly 184 are there. So this is my first frame, yeah. Okay, so if you see here, I can play, I'm trying to play, it's like all the images, maybe I'm more of a static, but actually all the frames are kind of, if you play it's giving slowly a video illusion. It's nothing but, video is nothing but you play different images with more frame rate. So like that I'm able to capture each frame. For 1 second, 30 images are converting. So 5 seconds, 5 into 30, 150, maybe 6 seconds, that's like close to 180 we got. So like that we are able to capture all these things. So this is how you convert frames to images. So now we have converted this session 6. Now in session 7, instead of we will be totally talking about RTSP stream. I mean, instead of locally doing all the things, we just read the data from the camera and send it to the network using or TCP IP in the form of RTSP protocol, and any RTSP client or a VLC player can read that stream. So instead of doing things locally, now we will go the video things over the network, how the video things will play over the network, and also we'll go through some video terminologies related to the network. So what is how to stream a video over the network, what are the different things that we need to take care, like all those details we'll be discussing in the next session, and also we'll be sharing this project details. So hope everyone has enjoyed this video.